Now see next chapter, that is gravitation. In gravitation, first part is their Kepler's laws. In Kepler's laws, first one is law of orbits. According to this law, all planets revolve around the sun in an elliptical orbit. So this is an elliptical orbit and the sun is situated at one of the foci, and the planets once comes to the closer to the sun and once away from the sun, very far from the sun. The A is the farthest point from the sun and this is called aphelion, and the P is closest to the sun, that is called perihelion. So all the planets are revolving around the sun in an elliptical orbit. Now see Kepler's second law, that is called law of areas. According to this law, all the planets sweeps out equal areas in equal intervals of time. So see here, the line joining the sun and the planet sweeps out equal areas in equal intervals of time, that is aerial velocity of the planets remains constant. Now see, this is the third Kepler's law, law of periods. According to this law, the square of the time period of the planet around the sun is directly proportional to cube of the radius of the semi major axis of the ellipse, that is t square is proportional to r cube. So r is the radius of the ellipse, that is actually the semi major axis of the ellipse. So this is the third law of the Kepler's, that is law of periods. Now see here, we have seen three Kepler's laws. One was the law of orbits, second one law of areas, and third one was the law of periods. Now here, explanation of the law of areas. We can also say that is geometrical meaning of angular momentum here. We have already done angular momentum in the previous chapter. Now let us understand. See here, there is any particle at the point K that can be considered as a planet also, and this whose position vector from the origin is, that is r. And now this point goes from K to L in time interval, suppose delta t, then its position vector becomes now r plus dr. That means the displacement is here, that is here the dr. Now I have just draw a line parallel to KL, that is OM, and join this line L and M. So this has become OKLM is a parallelogram. Now we can see the area of this shaded portion which the particle has covered. This small area, magnitude of the area can be written here, half of area of parallelogram, that is OKLM. In cross product of two vectors we have done here, this is magnitude of the cross product of two vectors, that is r and dr here. So dA can be written, this area of this shaded portion can be written half r cross dr. Now divide both the sides by t, you will be getting dA here, that is dt, is equal to 1 by 2 r cross dr upon dt. dr upon dt can be written as velocity. So we can write 1 upon 2 r cross here v, and this v we can replace by linear momentum. So we can write here half r cross p upon m, here is p vector. Now this is 2m. So we can take to this side, so we will be getting 2m dA upon dt is equal to, now here r cross p here left behind, that is equal to L. So here angular momentum. So see here, magnitude of the angular momentum is equal to twice of m dA upon dt. dA upon dt is the time rate of change of area. Now this dA upon dt quantity is known as aerial velocity. We know it. In case of the planets, there is no external torque, so L remains constant, 2m is already constant, it means dA upon dt is constant. dA upon dt is constant means aerial velocity of the planets remains constant.